9.3, we're continuing with our trig function, so it kind of brings in what we've done in 9.1 and 9.2 and puts them together. So yesterday we graphed angles. So today we're going to be finding trig functions of those angles. So again, it brings back what we did in 9.1 and in 9.2. It says you can generalize the right triangle definitions of trig functions so that they apply to any angle in standard position. So these are 6 trig functions. We have sine of theta. Sine of theta is equal to y over r, and I'll explain where the y and the r come from in a second. But what's the reciprocal function of sine? Anybody remember? Cosecant. So if sine is y over r, for cosecant we just flip it. It becomes r over y. For cosine, what's the reciprocal function of cosine? Secant. So cosine is x over r, so secant would be r over x. And then the reciprocal of tangent is cotangent. So tangent's y over x, cotangent is x over y. It just flips. So those x, y's, and r's come from a point that we're going to be given. So we'll be given this point. It'll be a coordinate point. So the first number is going to be our x value. The second number is going to be our y. It won't give you r, but we can find r. So given that point on a line, and our axis, it's going to form a triangle, a right triangle. And if we have 2 sides of the triangle, this would be x, this would be y. If we have 2 sides, how do we find the third side? Pythagorean theorem. So we can find r using x squared plus y squared equals r squared. So r is always going to be our hypotenuse. So r is the hypotenuse. And it's always positive. When we form our triangle, so the last thing we want to note here, we drop the third side, so it's not going to give you the little triangle, you kind of have to create it. You drop the third side to the horizontal line, so it's either going to drop down or drop up to make the triangle. It'll never go sideways. So what I mean by sideways is we don't form the triangle going this way. Doesn't go sideways. It either goes up or down to form the third side, and we'll see it in the next example. Well, the next example drew it for us, so that's good. But notice how the third side of the triangle, the line just drops down. So here is our right triangle. For this question, we have to evaluate the 6 trig functions of theta. So we are given x. What is x? -4. And what's y? 3. So if it helps, I would draw it on your triangle. X is -4, so x goes left and right. Just notice how we have the x-axis here. So this value here would be -4. The y value, y goes up and down, so that would be 3. Now what do I need to do to find the third side of the triangle? What do? Pythagorean theorem. So that would be a squared plus b squared equals c squared. What would our c squared have to be here? R, the hypotenuse. Remember, your hypotenuse is always the c squared. So we have 3 squared plus, well, it's plus -4 squared is equal to c squared, which we could just call it r squared. Everybody with me so far? All right, so let's solve for r. 3 squared is 9. What is -4 squared? 16, positive 16, because it's -4 times -4.
You have this calculator, right?
Mm-hmm.
What is it?
So if you put it in the calculator, make sure you put it in parentheses, because then it'll turn positive. But it makes sense, because a negative times a negative would give you a positive. So 25 is equal to r squared. How do I find what just r is? Square root. So what's r? 5. Awesome. So our R is 5. So we have to find the 6 trig functions. So we want to find sine of theta, cosine of theta, and tangent of theta. And then we'll find the reciprocal ones too. What's the reciprocal trig function of sine? Cosecant. What about for cosine? Secant. And what about tangent? Cotangent. Awesome. So on the last page, it gave us that sine is y over r. But instead of memorizing those, what we can do is we know that theta comes from the center here. So this angle here is my theta. Using our SOHCAHTOA, sine is what over what? Opposite over hypotenuse. So which would make sense because y is 3 and r is 5. So you could just use your SOHCAHTOA to help figure out your 6 trig functions once you have your triangle. So what would sine of theta be? Which is 3 over 5. Cosine, on the last page we said was x over r, but we also know that cosine is what over what? Adjacent over hypotenuse. So adjacent is -4, so -4 over 5. Tangent is what over what? Opposite over adjacent. So what's opposite to our theta? 3. And what's adjacent? So 3 over -4. And then for our reciprocal functions, what do we need to do? Just flip them. So cosecant theta would be 5 over 3. Secant would be 5 over -4. And cotangent theta? -4 over 3. Awesome. So these are our 6 trig functions. So remember that theta always comes from the center. It's important to know. Theta because when drawing triangles before, theta was always given to us. Here it's not going to tell you where theta is. If you put theta up here, your values would be different. Your sine, cosine, tangent would all be different. It always comes from the center for your theta. So slide 4 talks about the unit circle. So the unit circle, we'll see on the next page, I put one on it, but it has all of our special angles on it. And for the unit circle, our R value is 1 because it's just saying that the circle that we're dealing with here is just 1 unit. So that's why R is just always going to be 1. So instead of sine of theta being y over r, sine is just going to be y. And cosine is going to be x. So it's important to know that sine goes with y and cosine goes with x. Also from the first page for tangent of theta, tangent is y over x. So the tangent value doesn't really change when you're dealing with the unit circle, but it is y over x. So that one's important to know too. So you just got to know these 3. And then the reciprocal functions, we just flip, just like we did before. All right, so example 2, it says use the unit circle to evaluate the 6 trig functions of theta is 270 degrees. So what we're going to do is go to our unit circle. We need to find 270 degrees, which is right here. So we're going to use this point here. So what would our x be? 0, perfect. And what's our y? -1. So then let's find our 6 trig functions. So we're using the point 0, -1. So when you're using the unit circle, all you need are your 2 points. So this is x and this is y. So we have sine of theta. Sine is which one, x or y? Y. just like we said on the last page. Sine is y. So sine of theta would be just the y value, -1. Cosine is which one? Perfect. Cosine is x. So what's our x value? 0. So cosine of theta is 0. Tangent is what? Y over x. So here we have -1 over 0. Can I have 0 in the denominator? No. So what do you think this is? If we can't have 0 in the denominator, it would be undefined. Or you could say no solution. I think it's the same. No solution would be fine. It's just undefined because you can't have 0 in the denominator. If you had 0 on top, then your answer would be 0. So let's find our reciprocal functions. So for our reciprocal ones, we have cosecant first. Instead of it being just y, it's 1 over y. So here we would have 1 over, our y was -1. What's 1 over -1? Just -1, perfect. Then for secant, secant would be 1 over x. So it would be 1 over 0. What did we say when 0 is on the bottom? What happens? What's our answer? Undefined. And then lastly, we have cotangent. Cotangent, we flip tangent, so that would be x over y. So instead of it being -1 over 0, it would be 0 over -1. And what's 0 over -1 simplified to? 0. So you can have 0 on top, you just can't have 0 on the bottom. If you have 0 on the bottom, it would be undefined. So these are 6 trig functions. So when using the unit circle, you just have to find the value on the unit circle. That's your x and y, and then just make sure you know that sine is y, cosine is x, and tangent is y over x. Let's take a look at number 3. So first thing we want to do is form our right triangle. So how would I form the right triangle here? It doesn't give it to us, but how could I make one? Which direction would I put that third line for my triangle? I have one here and one here. So do I put the third line sideways or do I put it up and down? Would my triangle go here? No. R cannot be negative, correct. So you always make the third line of your triangle going towards the horizontal line, so it's either going to go up or down. So in the last one, we had a line here, we put it down. So this one, just because our line starts down, we have to move it up there. But it never goes sideways to make that triangle. Bless you. All right, so we've got our right triangle here. What is x? -5. What's y? -12. So for my triangle, what would this value be? How did we know that that's -5? Because it's on the x-axis. So this would be -5. What would this value be? -12. What would this value be? C squared. Yeah, it would be C. It's our R. But what do we have to do to find that? Pythagorean theorem. So we have -5 squared plus -12 squared is equal to C squared. Or we could say R squared. Because we're looking for the radius here. So 5 squared is 25. What's 12 squared? What's -12 squared? 144. 25 plus 144? 169. Take the square root, and what's R? 13. Awesome. So now that we have all 3 sides of our triangle, this is just like what we did in 9.1. We want to find our 6 trig functions. So if you need to, write down SOHCAHTOA. and sine, cosine, tangent. What's the reciprocal trig function for sine? Cosecant. What's the reciprocal trig function for cosine? Secant. And the reciprocal for tan? Cotangent. All right. So where do we put our theta in our triangle here? Where would our theta go? Closest to the center here. Theta is going to be at this angle. So what would opposite over hypotenuse be for sine? What's our opposite to the theta? Negative 12. So this would be negative 12 over, what's our hypotenuse? 13. So negative 12 over 13. So cosine is what over what? Adjacent over hypotenuse. So what's adjacent? Negative 5 over 13. So if it helps, I would label everything. Because this is your theta, so you know that negative 12 would be opposite, negative 5 is adjacent, and 13 is your hypotenuse. So label it. That way it's easier just to plug in when you're doing your SOHCAHTOA. All right, and then for tangent. Tangent is opposite over adjacent. So what's our opposite? Negative 12. And what's our adjacent? Negative 5. Can I simplify this? Are you sure? What's a negative divided by a negative? Positive. So this would be positive 12 over 5. All right, and then let's do our reciprocal ones. What would cosecant be? (13 over negative 12). What would secant be? 13 over negative 5. And cotangent? 5 over 12. Perfect. So these are our 6 trig functions. So for number 4, we want to find these 6 trig functions of 180. So we're going to go to our unit circle, find 180. What's our point at 180? What is the xy coordinate at 180? Negative 1, 0. So what's our x? Negative 1. And what's our y? 0. So we're going to plug it all in. So let's find sine first. Sine, are we looking at the x or the y? The y. So what's our y value? 0. Awesome. Cosine, what do we look at? The x. What's our x value? Negative 1. Tangent, what are we looking at? Y over x. So that would be 0 over negative 1. What's 0 over negative 1? 0. Perfect. We can have 0 on the top. You just can't have it on the bottom. So it simplifies to 0. Let's find our reciprocal one. So we have cosecant, secant, and cotangent. So we just flip it. So instead of it being y, it's now 1 over y. So this would be 1 over, what was our y? 0. Can I have 0 on the bottom? So what would cosecant be? Undefined. Secant would be 1 over x. So that would be 1 over negative 1, which simplifies to negative 1. And cotangent would be what over what? Awesome. X over y, which would be negative 1 over 0. Can I have 0 in the denominator? This would be undefined. Awesome. So these are our 6 trig functions. we're going to talk about reference angles. So it says let theta be any angle in standard position. The reference angle for theta is the acute angle formed by the terminal side of theta and the x-axis. So reference angle is an acute angle formed by the terminal side and the x-axis. So to come up with our reference angle, so we call the reference angle theta with a little line on top, theta prime. It's just a way that we can name the reference angle, so we know that we're talking about the reference angle, not the actual angle. So depending on what quadrant we're in, we have a different formula to come up with the reference angle. If we are in the first quadrant, quadrant 1, whatever theta is, that is what our reference angle is. Doesn't change. If we're in quadrant 2, to find our reference angle, we would do 180 minus theta. For quadrant 3, our reference angle would be theta minus 180. And then if we're in quadrant 4, our reference angle would be 360 minus theta. So it depends on which quadrant you're in, you use a different formula. Your reference angle is always going to be acute. What does acute mean?
90.
Less than 90. So it's always going to be acute and positive. So if you used one of these formulas to find your reference angle and you get a number that is not less than 90 or not positive, you probably plugged it into the wrong formula. So try again. So it's going to be one of these depending on which quadrant you're in. So these are your 4 little formulas that you need to know to find your reference angle. But it helps to know that it is always acute and always positive, because if you get a number that's not positive, you plugged it into the wrong formula. So in example 3, we have to find a reference angle for 5 pi over 3. Well, how am I supposed to know where 5 pi over 3 is on my unit circle? It's a lot harder to see where radians are, but we can see where degrees are. So let's convert it. Awesome. What do I need to multiply by to convert this to degrees? 180 over pi. So we want to simplify before we multiply so we can cross the pi's out. We can divide 180 by 3 and get 60. So then we just have 5 times 60, which would be 300 degrees. So where would 300 degrees be in which quadrant? It would be in the 4th quadrant. So in the 4th quadrant, what's the formula that I use for the reference angle? (360 minus theta). So 360 minus the angle that we were given, 300. What's 360 minus 300? 60. Now the only kind of tricky little part here is if your question is given to you in radians, your answer has to be in radians. So what do you think I need to do? Convert it back. So we're going to multiply by what? Pi over 180. Perfect. So we multiply these together. We can simplify. Cross off the zeros. How many times does 6 go into 18? 3. Thank you. So good morning. We're left with pi over 3. So that would be our reference angle. This is theta prime. All right, let's do the same thing for B. So we need to find the positive coterminal angle of this. How do I find a positive coterminal angle? Add 360. So we would get 230. So what quadrant would 230 degrees be in? Which quadrant would 230 be in? The 3rd. Yep, and 3. Because this was 90, 180, 270, so it's going to be in between 180 and 270. So what formula do we use for quadrant 3? Theta minus 180. Perfect. So this would be 230. 230 minus 180. What's 230 minus 180?
Or 50.
50, so 50 degrees. So our reference angle is 50 degrees. So let's look at number 5. We have 210 degrees. What quadrant would that be in? The third one. What formula do I use for the third quadrant? Theta minus 180. So this would be 210 minus 180. What's 210 minus 180? 30 degrees. So our answer is 30. Let's look at number 6. What would I have to do first for number 6? Find the positive coterminal angle. So what do I have to add to this? Add 360. So negative 260 plus 360 would be 100. What quadrant is 100 in? The second quadrant. What formula do I use for the second quadrant? (180 minus theta). So 180 minus 100 would be 80. You guys awake today? So 7's in radians. What should we do first when it's in radians?
Multiply by 180 over pi.
Awesome. We want to convert it, so let's multiply by 180 over pi. So the pi's cancel. How many times does 9 go into 180? 20. So then a negative 7 times 20 would be negative 140. We still have a negative angle, so what do I need to do to find the positive one? Add 360. So when we add 360, we get 220. What quadrant is 220 in? Third, because it's in between 180 and 270. So what formula do I use in the third quadrant? Theta minus 180. So 220 minus 180. This would give us 40 degrees. Can I leave my answer in degrees? No, why not? What was the question in? Radians. So our answer has to be in radians. So what do I need to do? Awesome. Multiply it by pi over 180. So we want to simplify. We can cross off the zeros. 2 goes into both 4 and 18. So that would be 2 pi over 9. This is our theta prime, our reference angle.